Hello, my name is Stephen Brennan, and I'm here for our last Excel report number 3. And here in scenario 1, we're talking about the difference between theoretical and empirical probability, and we are showing it with two dice. And I always found this interesting because at school we always talked about, oh, you flip a coin, it's 50-50. But like they always show us it's in math it's 50-50. In theory it's 50-50, but it's not truly 50-50. Oh, when you flip a coin. But like I've always wanted to see what would happen if we did that an infinite amount of times, and we actually did that in this one down here. But I'm getting ahead of myself. Over here we rolled a dice, I think 6 times, yes. And of course, just random numbers. We used Excel. There's your formulas. Um, and then we did it, I think it was 60 times over here, all the way down here. Then I believe this one is 600, and then 6,000 all the way down here. And I'll get into these graphs while I'm reading the report part of the report. Theoretical probability is an expected probability based on the knowledge of the situation. The empirical probability of an event is given by numbers, the numbers of times the event occurs divided by the total number of incidents observed. Theoretical probability, on the other hand, is given by the number of ways a particular event can occur. So basically what I was just talking about earlier, how it's 50-50 in by math, it should be 50-50. Well, with the coin example I'm going with, because it's the most simple example you can give. It's not always 50-50, even though in math it should be, but in reality it's just not. And the law of large numbers is the principle of probability. Given enough instances, the results will always end up looking the same. Generally, as the numbers of experiments increases, the actual ratio of the outcomes will coverage converge. I forgot to spell check these with Microsoft Word. Converge on the theoretical or expected ratio on outcomes. And I took a screenshot from that website we went to, or you went to. I also went there, just a screenshot of it. And we rolled 20,000. I rolled 20,000 times that year, and we get an image that looks awfully familiar. And it always ends up that way. If given enough rolls, it will eventually look that way. And if we look over here, with 6 rolls, of course, that we just got a little something, something. It doesn't matter. I don't know why that's half. Oh, well. Excuse me. With 6 rolls, yeah, we have our data here. Okay. Doesn't look that remarkable. With 60 rolls, okay, a lot more. Getting a little bit of everything, but still not what this is. 600 rolls, we are starting to come on to what this is. It's just slowly creeping on into the distribution curve. And then 6,000, it looks awfully familiar, especially with the distribution curve. Oh, and I almost forgot to show, when you use the random equation in Excel, when you do something, like literally anything, it decides to do the random act again. And because these graphs are linked to this data, look what happens when and I have it on redo and undo, or whatever, you know what I mean. We can see that the data is changing, and is it random every time, or is it going to the same ones? Okay, yeah, it's going to completely different numbers each time. And because it's connected with these graphs over here, we can see that it's changed the data on the fly, like so. So that's just kind of neat, and that's done with the random in between whatever numbers you want equation in Excel. Handy Excel. And now for scenario 2, using binomial experiments and expected outcomes. With this one down here, over here, we showed that, well, we showed that using, in math, there's many different formulas to get the same thing. All these are different formulas that get us the exact same thing. And that one, this one was annoying. And then, of course, Excel does it for us, handy Excel. And over here, oh yeah, lottery tickets. Yes, we were talking about the probability of lottery ticket winnings. I can't believe I forgot that before I pressed resume recording. And we were just basically talking about your initial investment with the first ticket, and then the probability of winning. And of course, it's awful, and nobody should play lottery in general. But that's besides the point, I guess. Because yeah, that looks very. Yeah, I can be that one person right there. And for our report, define the relationship between binomial distribution and normal distribution. Well, binomial distribution is discrete. It's not continuous. And like as we can see here, with all these probability fractions, all these probability fractions over here, they're not like an equally chance to what's the word? It's not a steady rate of decreasing your amount to win. Like this one is 114 to win $5. And then this one is 1 out of 8. And then this one is 1 out of 40. And then the next one is 1 out of 48. All these are random. Well, random, strategically placed, so you can get your hopes up. And like this one, this is the most drastic one, to win $100, it's 1 out of 30, 35. 150, or 350, I can't speak. And then the next one just jumps up there at 1 out of 3,400. Don't play the lottery, guys. Okay. It's just not good. And then the perspective of the lottery ticket buyer and sellers. From a regular person not looking at the odds, if I did, okay, let me go back over here. If I didn't know these odds, I would think, oh, I have a chance to win. And as long as I have that chance, I believe, I have hope. But when you're not looking at the odds, it's easy to have hope in something. But when you're looking at when you are looking at the odds, it's very easy to just dismiss everything about this lottery. And yeah, and from this perspective of seeing the odds, the lottery is just a sham, especially when you notice that everything's strategically placed. So you think so you hear about enough people winning a little money. So that one person's got to be me eventually. And like I already knew that for the most part. Of course, it's the lottery. They kind of want your money. Yeah, but now I can prove it mathematically right here. And from the seller's point of view, like the people selling the lottery tickets, like gas stations, or of course the people who make the tickets, that's probably what you were asking. They're making bank. I mean, that's what the lottery is. People just burn their money, throw it at these companies, and then they make a huge profit. Oh no, somebody wins. Okay, they got to give them a small percentage of what they've gotten total. And describe how understanding expected outcomes can help you make informed decisions. This data table is a fantastic example. I would never buy one of these tickets, but well, okay. Normal person would probably buy these tickets, but I would have never bought these tickets before looking at the data. And now, after seeing the odds, I'm definitely not buying all these tickets. Why would I do that? Why? I like money. Why would I want to burn it? And just looking, and normal people just looking at the straight facts, the straight odds, people will at least hesitate. They'll probably still buy it, if we're being honest here. But people will begin to hesitate but buying something like this when they see the lucrative odds placed here. And like even our Arkansas jackpot, I think this was for the scholarship lottery. I think I don't remember. Um, to win first prize is 1 in 557,757. It's a better chance to win this lottery, but of course, is that less money? I don't remember if it's actually. Yeah, I think it's significantly less money, but the chances are still not good. And a 1 in 9 chance to win anything. Yeah, a 1 in 9 chance to win anything. So, yeah. And now, scenario number 3: exploring statistics, American body's mass index, and where do you rank? For this one, we were looking at the averages of women, I believe. No, no, that's not right. Yeah. We were just looking at the body index percentages of American women, and yeah, men over here. And then you had us look at the. Oh, my camera's drooping down. All right, there we go. I kept hitting the table so much the camera started drooping down. Just hanging on my TV. But anyway, we had to find our Z scores for the body mass index, which I don't see as a reliable source, to say the least. It was heavily updated, but we're about to get to that. So you had us use the snip tool to use this. I forgot what it was called, but it was basically our Z scores to find our exact numbers here. And then I color coded me, my sister, and my mom. And of course, my mom is really, really tiny and skinny and unhealthily so. And that's why on the distribution curve, the bell-shaped curve, hers is 16, which her Z-score would be negative 1.9 or something like that. Oh, yeah, so it's right there. And then my sister, she's basically in good shape, but she is slightly above average. Of course, the average being dead center right there for the average of all American women. And as Miss Binzi thought I said, bi American women, as in bisexual, even though that's what she wrote. She saw my computer and she was really confused what that meant because she forgot her own thing. But anyway, now to me, I'm obviously not the best tool in the shed, to say the least. My BMI is 40, and my Z score is about 2. Or wait, no, it's not. It's about 3. Wait a minute. Oh, okay. I'll just fix that later. Anyway, to the report. Find in your own words, what is the BMI, the body mass index, that the American system has made? The body mass index is heavily outdated system. It's just existed for I think like 50 years or something like that. And it basically just says, are you healthy or not? It's very generic, and even everybody knows, even when we had to take it at school, like, okay, we have to do this, but we know it's not that reliable. Even all the teachers and principals were saying that. Like, oh, wow, that makes me feel like I'm not wasting my time. On explain confidence intervals. Confidence intervals are basically the data in which it is most probable for the test sample to fall in. To be exact, it is the 95% chance. It's the 95% chance that everybody will fall in. And in fact, the link in these reports, I meant to put a link in here, but basically it's just all this except the purple. And the purple should be smaller if I'm being honest. But you have a 95% chance to landing anywhere in here. And I think this was like 2%. Yeah, it's 2.1%. It says over here on this purple. And my mom's, and my sister's Z scores are just where our marker would go on this map. map graph to see how healthy we are. And I'm not saying I'm not healthy. Of course, I'm not particularly the most healthy person out there, but I'm just saying as just a whole, the body mass index is just not a good, reliable system that you should take 100% at face value. Oh, and I guess I should show some formulas. I keep forgetting to say that because I'm just too busy in talking, just explaining everything. Okay, so now scenario 4, simple and compound interest rates and loans. And here, I zoomed it out for you because this took a lot of room. For this one, we were just talking about the most likely scenario. Let's just say you put money in a bank and there's interest on it, or you gain interest on it. And it's always simple interest. But basically, we were talking about you bank loans you money, or you put money in whatever. Okay, how much is that going to grow with a certain percentage? And as we can see, simple is just increases at a steady rate. Simple interest, it just increases at a steady rate, nice and slowly, and it's pretty linear too, as we can see here. And I go to talk about this in my report. And I even brought a chart right here, even though I just totally forgot. I got a better one right here. Well, better one. This is nice and colored. Whatever, to each his own. And compound interest, we can see, is just increases dramatically. Well, not dramatically. It is you're definitely paying more with compound interest. So yeah, you don't want to do that. And basically down here, we were talking about mortgages. And, it's a long formula. Oh, yeah, that's right. I remember this. We were talking about mortgages and with the interest rates on those. And we do more of that in our financial report, which I already did over here, which I found very fun to mess around with. And like different down payments and stuff. Well, that's besides the point. That's for the next project after the homework. Connect math. And then down here, what was this? Oh yeah, if we paid extra, which I also go into that in my financial report, but we don't. I'll just go into it because I don't make a video on this anyway. We just turn it in. Where is it? Down here. Yeah, down here I did a mortgage of a home after like 5 years of spending or savings, and I just wanted to see. Okay, if I put a down payment of $80,000 onto this home, and I'm paying it back in 15 years, my end payment for this house, which would be $151,000, and I'm basically paying half of it right then and there, and through 15 years, I'm paying the rest of that with a monthly payment of $714. By the end of it, I'm going to be spending about $210,000. That's because that $50,000 or $60,000 of that is interest. But if we go down to here, I put the same down payment on. The house is the same price. It's the same home. But when you change the years, that over here, you can see that the interest goes up exponentially because you're wasting. You're spending more time to pay the bank back their money. So they're going to get more in return. So when buying a house, the ideal solution would be that. Of course, not everybody can afford that. And down here, it's just the same thing, just with a different down payment, but same amount of years. It's still pretty even, as you can see. Anyway, that was a bit of a tangent, but I felt like that explained it a lot more than this, mainly because I did that more recently. But now to the report. Explain what interest is and why it exists. Well, I basically already did that. Interest is the money one must pay by borrowing, usually from a bank, more than likely from a bank, or at least reliable if you do it from a bank. However, it could be also beneficial for the individual with money growing. Like if you put your money in a bank, of course, there's interest on that. and your money is growing a little bit, barely nothing, unless it's a large sum, then you can see a decent amount of interest. So it works both ways, but of course it's more beneficial to the bank. But it exists because it is a way banks get their money. I mean, it's that simple. Like, that's how they stay in business, is the interest. That's how they make their profit. Also, the longer you wait to pay for it, the higher the interest gets, as I was showing in my financial report with my home. Okay, and explain the difference between simple and compound interest. Simple interest is linear, obviously, as we can see here, and in the graph right here, but this one is a little more cartoony and easier to read. It's a linear way of paying one back, and that usually, I think, for most cases, it's simple interest. A certain percentage every day or month in the case of a house, or any other interval of time. Compound interest is a certain percentage compounded daily, basically interest on interest. So you don't want to pay a car back with compound interest. If a car dealer offers compound interest, just turn around and walk away. You don't want that. Discuss the benefits of eating out money to make extra payments on your mortgage. Extra payments on something like a mortgage, like a home, as I was saying here, would, in the long run, it would lower your total cost. It will save you money if you pay extra than what the payment requires. So if I go to my financial report, I know this isn't part of the Excel report of the 6 scenarios, but I think it just explains it too well. For this, you can see, back to this example, I was paying $714 a month, and my in payment would be that much. But if I paid $800 a month, it would be, I could actually do that. If I put 800 into here and just paid extra than the bank is asking the bare minimum for, which I think you can pay less than what the bank asks for, but then I think that's a penalized. You get penalized for that, but that's besides the point. But let's say I want to make extra payments, more than what the bank is asking for every month. If I put 800, wait a minute, hold on. Oh, right, of course, this isn't a complex formula. But basically, in real life, if I paid an extra $100, like if I paid $800 instead of $714, what the bank is asking, and this is my original in payment, my in payment, if I paid $800 instead, would be at least a few grand cheaper at the end of the day, because that would result into less interest. I believe. I'm pretty sure that's how it works. But basically, you'd be paying less for that. So it's always good to pay a little bit more, if you can, of course. Not everybody can. That's just a fact of life. And explain the differences between subsidized and unsubsidized student loans. Direct subsidized loans have slightly better terms to help out the students with financial needs. That's a lot of S's. Subsidized is, in my mind, I just think of it, and that's basically simple interest, and unsubsidized is basically compound interest. Basically, you don't want unsubsidized. Of course, it's also depending on your scenario. If you're paying it back really fast, or if you can't pay it back in a long time, you're gonna want subsidized, because it's basically simple interest, not compound interest. Because, like, I guess talk about that with compound interest, the longer you wait, the more you're gonna pay. And of course, that's the same with simple interest, but compound interest, it just goes up and up and up and up way faster than simple interest. And I don't know what these are, probably months or something. But you get the point. List pros and cons of paying interest, and list a couple of strategies to avoid or minimize interest payments. The pro for interest is that the banks give you money to do it, basically to like buy a house or cars, what have you, if you really need it. And of course, for most cases, like when you buy a house, you're taking money from the bank, right? And then you're or the real estate office, and then you're paying it back. So you don't own. Well, okay, well I get into that. And of course, the cons are you have to make extra payments at the end of the day because of the interest, and also you don't technically own anything until your payments are fulfilled. Like my dad's house right here. Yes, I still live with my parents. um, he still doesn't own this house because he's still making payments. So it's just a weird thought if you think about it that we don't own this house. And of course, that's a case with especially the case with cars. I mean, repo jobs are very mucho más. It's a very sought after profession to be a what are they called, repo man, whatever, what have you. Because when people can't make their payments, a repo man would go and take the car back to the dealership, and then they can sell it again and make more profit. Capitalism. Okay. Scenario 5, gathering data from the populace and samples. And in this one, we were talking about different types of ways to get samples to do like studies or what have you. And I talk more about that in our report over here. Or yeah, I guess I should go ahead and go right into the report. Oh, I forgot to title those. Oh well. Question 1: explain random sampling. Explain the different types of sampling in the context of taking a survey for the voters to learn the overall voter population. Okay. Um, Random sampling is 100% random people chosen, not really reliable for the most part, especially for something like this, because you could, let's say, do a random sample of a state that's Republican, and the Democrats are in the heavy minority. Then you don't really want to ask them political stuff, like political ideologies or something like that, because then it's just not reliable. Stratified sampling is done by taking the general populace and putting them in subpopulations, then randomly picking from those, which it's basically random sampling, except a little more profound. It is, what's the word I'm looking for? It's a little more exact. It's just, it's still random to an extent, but there's some math into it, and it is better than random sampling. Try to combine two words there. This is very reliable. Volunteer sampling is when one comes to you, not totally random. So this wouldn't be reliable because because we did political. I keep going to that example. Let's say I do like a pro-life poll in like who's pro-life? Democrats? No, Republicans. Republicans. Let's say I do that in a Republican state to see how the general U.S. population feels. Well, I don't want to do that. Ask for volunteers in a Republican state because then it's just not even. And convenience sampling. Wait, is that the name? Yeah, convenience sampling is basically the same thing, just asking anybody close to you, like at a mall or something. And I guess that's a little more reliable than volunteer sampling. And discuss a survey topic that would be appropriate to use volunteers or convenience sampling. One survey topic could be something like people's opinions on anything political, but the sample would have to be taken from a non-political environment. I misspelled environment. Like a mall or something, just something totally random. But of course, then that's not totally fair because at the same time, it could be a more leaning state. And of course, then it's not really the best, but that's one I thought of. And relate conditional probability and stratified sampling. The conditional probability can influence stratified sampling if it wasn't done to the best of its ability. Explain why the population and sample are important when using data to project the probability into a larger population. Bias. Everybody has a bias. Even if you say you don't, you do. Even if you try to, like even we were talking about in report 1 all the way at the beginning of the semester. A website can say how, or a journalist's website can say how unbiased they are. It's impossible to be 100% unbiased. Everybody's a little bit unbiased. And it's the main concern when taking a sampling bias, especially like this. Like I think this one was Trump approval ratings. Yeah, of course, Republicans like him to an extent, and then Democrats don't like him, obviously. Where to go? There it is. Explain how using data from one population to project or report outcomes on another population can create confusing or misleading data. It's the same thing, bias. If you take a sample from a Republican state, as I've been saying this whole time, and then you ask them what they thought about President Trump, it would most likely be positive, where in a Democratic state, it would be mainly negative. I mean, it's just self-explanatory. That's how two-party system works, I guess. Anyway, scenario number 6, which was my favorite because it only took about 5 minutes. This one was fun. Let me go to the questions. Define 3D. Yeah, and here we did 3D graphing, perspective, all that stuff. Define 3D graphing in your own words. A 3D graph is a graph which takes form in a 3D form. It's just easy to read. And to explain that better, I think it's the next one. Explain the numbers on the Excel spreadsheet. Okay, well, in my mind, this is basically, and this one is this one. Yeah, it is. This is basically just this, but given depth, or the opposite of depth. Depth. It gives depth. Like we see all these ones here. In my mind, okay, that's just this over here. And if I go to 3D rotation, and if I get a top-down view of it, can I rotate it? Yeah, like that. This is basically that. Or, well, if I turn it, but whatever. These numbers are basically just this. Right now, that's basically just the graph with shading. But this just gives it, wrong button. This just gives it shape, form. It gives it new form. Oh yeah, and then for some reason it does that. Like it changes the axes intervals when I sometimes rotate it. I don't know why, but I found that interesting, and I think that's a question down below. And of course, it's hollow underneath, because why would you want to render it being a solid? That'd be pointless. Rotation, yeah. I mean, it's just, the numbers are just this, just given form, quite literally. And then, of course, the same thing for this one, and then this little guy. Wait, why does that look weird? If I expand it, it'll probably, yep, it will change. I don't know why it does that, but it does. Anyway, the next question. Explain the number, explain why changing some of the values on your image while changing other values does not change. Okay, well, like I said, how I view this, and I'll pick this small one because it's the easiest to comprehend. If like I said, I view these as this 3D graph is just that table taken form. It's literally just risen. Like that number 3 is that right there. These are number 2s. This is number. Wait, why are there 4 colors when there's 3 numbers? Oh, because it's doing the, yeah, when I expanded it, it did that thing. It changed the intervals like that. But that's beside the point. If I take this and if I change it, oh, enter. There we go. Then it kind of has a little growth. Like a tumor. Rotation. Yeah, and it's literally, it just took that and just brought it forward. And of course I can undo. Oh, great. It'll just do the rotation. Oh, whoops. Yeah, like that. It just totally just, because as we can see, this is basically a nice little pyramid with the foundation of ones, then the next step of twos. But then if we mess that up, not really a good pyramid anymore. What question now? Discuss the differences in graphical images depending on rotation and perspective. Well, I mean, depending on how we look at it, I mean, it's the same graph all around. It's just because it's 3D, we can just look all around it. And it's just easy to understand, especially if it was, of course, a little more complex numbers than just these simple 1, 2s, and 3s, and up here, in this case, 4. It just, if this was more complex data, we could take a look at it. Just like, I don't have the image pulled up, but just like the image Miss Benzie had in her video where it had the 3 spirals in it, like more complex data, it would be useful to look all around it, underneath it, and all that. And then explain why examining different perspectives of information is important, and name a few situations when changing your perspective may make a difference in your decision. Where is it? 3D graphs can be used for projecting multi-dimensional data, basically everything I just said, into visual form. I tend to do that a lot. I explain everything before I even get to it on my report. Then I just sound redundant. It's the visual form, easier to understand. I can't read because my webcam wire's in the way. Analyze and interpret. Good for something like industrial industry. I actually saw an article when trying to find like how could this be useful in different types of fields other than like science or something. I saw a few articles that they're trying to implement this technology into construction, which I guess makes sense. Maybe not to the form of Excel when it's just simple numbers. That doesn't really make sense for that specifically. But 3D models are usually a good way to go. All right, well, that is my Excel report. See you later.